Hello everyone, it's Steve. We're now going to complete the square to find zeros of a quadratic. So our problem is going to look like this. Solve negative 2x squared plus 12x minus 50 equals 0. So this one might not look so bad at first. I do remember that if I'm going to complete the square, I can't have anything in front of the x squared other than a 1. So this negative 2 right here is going to have to go. So what I'll do is I'll just divide every single term by negative 2. So divide all 3 terms by negative 2. So that's not only going to cut them in half, but it's going to change their sign. So first term will become x squared. 12x will become minus 6x, because you got to change it to a negative also, not only cut it in half. And we're going to get a plus 25 here. So far so good. We don't even have any fractions. I think we're in good shape. In fact, we're in such good shape, one might even think it's possible to solve this one just by factoring. But if you try to solve this by factoring, you're probably not going to get too far. So we're going to complete the square. And now that we've made sure that we have just a positive 1 in front of the x squared term, we're going to move our constant to the other side. So let's go ahead and subtract 25 from both sides. Okay, now we take a look at our important number, which is the number not in front of x squared, but the number in front of x. So it's a 6. Nope, it's not. It's not a 6. It is negative 6. Cut negative 6 in half, get negative 3. You square negative 3, you get 9. That's the number we add to both sides of the equation. So we'll put a plus 9 there, plus 9 there. So we're going to get x squared minus 6x plus 9 equals negative 16. The left side should be able to factor as a perfect square. No guesswork here. Because of this minus 3 right here, we know the left side just factors as x minus 3 quantity squared equals negative 16. Now we take the square root of both sides because we want to get rid of that squared that's on the x minus 3. And this is when we run into a little bit of trouble because we are now taking the square root of a negative number, which means we are going to get 2 imaginary solutions to this. The zeros are going to be imaginary numbers. So left side, no big deal. The square root and the squared cancel, so we get x minus 3. And over here we still have the plus minus. Now I know that the square root of 16 is just going to be 4. And I know this plus or minus the square root of 16 is plus or minus 4. But if there is a negative 16 under there, then it works out almost exactly the same way, except you pick up the I. So on the right-hand side of the equation, we're going to have plus or minus 4I. Add 3 to both sides. And that's actually our 2 answers right there. They come in a complex conjugate pair. They are x equals 3 plus 4i and x equals 3 minus 4i. Because they're imaginary numbers, we can still say that they are zeros of the quadratic, but they do not correspond to x-intercepts. Only real zeros correspond to x-intercepts. So yes, we found the zeros. We win, but they are not x-intercepts. Thanks for watching.